Hello guys, and welcome to another video. Today I want to talk a little about the motherboard of the second desktop PC that I'm having right here. Is the motherboard is the G41 and the model is the Asus P5QPL-VM-EPU. This motherboard it does have the video on board, the VGA and the VI accordingly. It has the output optical right here and the HDMI. This is the output, the digital output, pardon, and PS2 and the mouse for the keyboard and PS2 mouse. And we have 4 USBs, one RG45 for the UTP cable, and the output the 5.1 for the speakers, these speaker surround systems that you may want to use. In this area we have the battery that we can reset the motherboard. It also has a jumper right here in this part right here, and this is the Biochip. And as you can see above from all the components here installed on this motherboard, we do have the Norwich heatsink, which is quite large. Is more like a tower. The reason for that is this heatsink is so tall because he needs to dissipate all our heat during the stress test and during the workloads and apps and games and overclocking. Will help to thermal dissipation. Will help to dissipate the heat better in this way. It also has the this copper is made by copper, and the fins of the copper is just very nicely made. Anyway, let's talk about the disadvantages from this motherboard. This motherboard it has only 4 SATA compared to the gigabyte that we saw on the AMD system. This is located right here. The 4 SATA connectors. Pardon. We do have the one PCI Express 16X, 1X, PCI Express 1X, and the other two that is PCI standard. What else? We do have the USB header that you can connect from the case, that cable, so you can have the in the front of the case the USBs. We do have the connector for the Realtek, so you can have the front panel Realtek for the audio, the microphone and headset, and right here in this part there are another 2 connectors for the other USBs that you may want to use. This motherboard only has two slots of memory instead of 4 or 6. I can tell that I've seen on another type of model, the gigabyte ones, that has 6 memory slots, and you can install more RAM on it. But from what I know is the DDR2 are limited to 8 gigabytes of RAM. And yeah, right here we have the CPU Z open, and I'm going to talk about the CPU. And we can see right here that we have the Yorkfield, the code name Q9550. It has a maximum TDP of 95 watts. The technology for this processor is 45 nanometer, and the core voltages that is working right now is 1.096 volts, and the frequency of course is 2.833. We do have the multiplier set by 8.5, between 6 and 8.5. We do have the bus speed 333, and the rated frontside bus is 1333. We do have the level 2 cache, which is very important because it's 2 by 6144 kilobytes, and we have a total of 12 megabytes of cache level, and the revision is 0. In 2008, pardon, they released 2 revision, 2 or 3 revision accordingly. I'm going to show you exactly how. So we do have the steppings for the all models that is support with all the technology, the Yorkfield name. We do have the stepping C0, C1, E0, and E0, of course. Each processor starting from Q9450 that was released in March 2008, and the price tag for this processor was 316 USD, to all the way up to Q9650. We see that the Q9650 is very different than his predecessors right here. We see that we do have a frequency at 3 GHz instead of 2.83 GHz, and we do have the multiplier by 9, set to 9, pardon, and we do have, compared to his predecessor, we do have the 8.5 limited for the Q9550. Of course, they released the Q9550S that is having the TDP of 65, but it does have the same amount of level 2 cache and the same frequency. The only differences between them is the Q9550S was released in January 2009, a year later than 2008, while the other ones were released in 2008, March 2008 and August 2008. The price tag for the Q9560 was 530, and for the Q9450 brother was released, of course, in March 2008, and the price tag was 316. I already said that. Anyway, what I want to explain about is those processors were very amazing back then, and they were able to run anything flawlessly without effort, and yeah, anyway, including the games. I do remember the guys from the YouTuber ones, they were playing, they were running this PCX2, PlayStation Emulator 2, and they specifically overclocked this processor to 4 GHz, and with GeForce 9800 GTX, and they were able to use this instruction set SSEE, pardon, 4.1. There was an option in that emulator that you can use, and all the games, they were working flawlessly. Yeah, and I was very impressed. But the processor, they were very pricey, and they were not very affordable, at least for the guys that they were trying to build the system back then. Yeah, anyway, what else? This motherboard, if you're trying to use the 1066 memory, I can explain more about the memory modules and all that. Let's focus on this area right here. We do see that we have the 4 GB DDR2, which is the memory is not a lot. It will bottleneck the system a lot, and the system will sluggish having this small amount of memory. But we do have the DRAM frequency set by 500, and if you divide that by 2, it will give you 1000 MHz. We see that the timings are 6, 5, 5, 18. Normally it should stay just like the Kingston said on his official website, 55518 or 55515, depending on how do you want to use it, of course. The motherboard always change it back to 65518. They're all dual symmetric modules. They're coming from the same memory kit, and it doesn't have any problem. But sometimes the motherboard, just like we saw these kind of things on the AMD ones, like I show you in my previous video, it will change it back to 655. Probably it doesn't like it, the timings anyway. I do have the GTX 460 right here. This is the GTX 460, the 1 GB 256-bit. It does have GDDR5 and having the Hynix memory, and the texture free rate is 40.7 gigatextile per second, and the bus speed is 256, like I said, and the bandwidth is 115.2 gigabytes per second. The GPU core clock is 726, and the memory is 900, and the shader is 1451 MHz. We do have the CUDA cores 336 CUDA cores compared to the GTX 9600 GT, 1024 memory for the video card, and of course that had like 64 or so, and this one is much higher. So yeah, I just reminded that I made the comparison back then than when I was using the GeForce GT 9600 that I have soldered out anyway. The disadvantage, now talking about the motherboard, the Asus P5QPL-VM-EPU, and of course is using the G chipset instead of P45. P45 is the latest and the greatest chipset that you can use for this LG775, and of course it's using the DDR3. Compared to the other boards, this board is not the greatest, of course, but you can use if you have a stronger CPU. It will support the 9550, 9450, 9550, 9550S, and 9650 at 3 GHz, and you can also use the faster GPU like Radeon 7950 or R9 280X, depending on your budget, and yeah, and all of that. And what I want to show you is when the CPU is idling, it doesn't doing the stressful things, tests or things, of course the apps, the two cores will stay at 29 or 30, while the other at 22, and the other two will stay at 41 and 41 respectively. I'm not sure why it's idling like that, but compared to the Linfield i5-750, where all temperatures were equal, but I'm going to investigate more, and I will explain how this thing works anyway. Yeah, let's go to the BIOS, but first I'm going to show you the results that I already made in Cinebench R15. And it looks like the R15 reset it somehow, and it's not a problem. We're going to run the test again. Now, comparing to the it's not the architecture, and I want to tell something important. This processor Q9550 compared to the i7-920, it has the memory controller in Northbridge compared to the i7-920 that is having the memory controller inside the CPU. So you have the memory access will be faster for the 920, the i7-920, of course, for the Bloomfield, even though it's harder, and you see that sometimes both processor are equal, but that seen from other tests, from synthetic tests that I've seen. But what is important is they move out to something faster. So in that period of time, the i7-920 was a better choice. So yeah, just try to remember that this processor is having the memory controller on the Northbridge of the motherboard compared to the i7 that is having the memory controller inserted on the CPU. And the memory controller will access, the CPU will access the memory controller faster. So that's why the i7-920 is a better CPU overall. Now, nowadays you can use the CPU for the gaming, for the browsing, for the movies, whatever you like, for the documents and then the Word, Office, but it's not very good for the CPU will not be a better choice for the editing videos, because it's not going to give you the performance that you need. All you need to do is just move to the latest generation of Intel, or the Threadripper from AMD, or the 5950X. That is the latest and the greatest from the AMD top of the line processor. And since it's finished, we have the 300 clean score. for the CPU, for the Q9550, and we are better than the i5 3370U CPU that is having 214 and is running at 1.7 gigahertz, but we're not better than all the i7 that is listed here right here. Now we're gonna go to the BIOS and show you a couple of things that I made, and we can talk more about that. Of course, the Need for Speed games and the MAME games and even some of the latest that is doesn't require the amount of VRAM for the video card. It will run on this system, no problem. But just try to remember that it's a quad core, and the quad core CPU is not relevant anymore these days, because we do have the fight of the multi-core processor all the time, and yeah. Anyway, first we're gonna focus on the jumper free configuration, so we can show you here a couple of things that I made. We do have the AI overclocking, and we do have the manual and the overclock profile. Here you can set the overclock starting from 5% to 30%, and you do have the test mode also, so you can test it yourself how the processor is, if it's stable or not, on each frequency, of course. We do have the right here. I'm not going to overclock the CPU because it's not worth it, at least in my case. So we do have the DRAM set at 1000 megahertz, and we do have right here you can increase the memory at 1100 megahertz for the memory. But if I'm doing that, it will the system will become unstable and it will crash. Not to mention about the blue screen of death. That is very annoying. And yeah, the reason for that is normally on the official website on the Kingston, they specifically said that if you want to use this memory, normally these modules are designed to work at 800 megahertz, just like any other, yeah, and the 1.8 volts, just the way you see it like here. And if you want to run it at 1066, which on this motherboard is out of the question, because you cannot run it at 1066 megahertz. The only thing that it works at 1000. And if you want to run it at 1066, like I said, in my case 1000, all you have to do is just increase the frequency from here and modify the voltages for the memory. And right now the memory will be stable. What it basically does is it just is overclocking the memory from 800 to 1000 megahertz, and this is how the Kingston memory module is working. If I increase higher than that, it will give me the error, like I said, and the system will become unstable. So it's best to leave it like that. 2.3 for the memory voltages and 1000 megahertz for the DRAM. Now we're gonna focus. Now if you go here, we see that the configure advanced the CPU settings. We have the C1E support that is enabled and all of that. Right here is set by default. The max CPU ID value limit is disabled. We do have the frequency 2.83 gigahertz, and right here at the chipset we do have the memory feature. Here the IGD graphics select, you can disable it if you want it, because here you can set the amount of memory that you can take from the memory system. So the onboard graphics card can take from the memory of the computer the 256 or 128, or the maximum DVMT. In Windows it will give you that you're having more than 1 gigabyte of RAM, 170, 80 or something. Yeah, and right here if you're using the separate graphics adapter, you can use the PEG/PCI. You do have the other options, but in our cases we do we're gonna have to leave it like it is right here, this by default PEG PCI Express, because that's what it means. Okay. Okay, in the Southbridge configuration, we do have the audio controller that is enabled. Of course, we do need that because it's our graphics, our sound card, and the front panel audio that you can use either for the AC97 or the HD audio. In my case, I'm leaving it just HD audio. The onboard system configuration. Here we have the onboard gigabit LAN and onboard boot ROM. Right here is another option that we want to use. The parallel port address and serial port. Yeah, the USBs that is having right here 2.0 controller, the high-speed controller mode. From the power right here, it's best to monitor your temps all the time for the hardware monitor. I did press enter, but it will take a time to enter this feature inside. So for the CPU we have the 28 degrees Celsius, and for the motherboard we have 27 degrees Celsius. It's better than the i7, pardon. I almost dropped my phone, I do apologize. And the CPU fan profile will be to performance mode, since I run the Cinebench R15. We do have the chassis fan speed set at 1300, and the power fan speed is the other that is using the Arctic Silver one that is made in Switzerland, is 1406 RPM. Right here we have the CPU over voltage. Here you can use this feature so you can overclock your CPU further, but in my case it's not necessarily, so I do not recommend doing that. Just putting too much voltages into your CPU and overclocking, it will break the CPU during time, and yeah, it's best to leave it on default, like it's there, the 1.1 or anyway. Let's go to the boot. Right here we do have the boot priority. I have disabled the third boot device because I'm not using it, so the only boot that I need is the Western Digital to start first, and the other for the second boot device is the DVD burner. Right here, if you want to update your BIOS, but you can use this option, so you can go to the EZ Flash 2 utility. So we see right here we have all the partition of the computer. There is C, D, E, F, G, H, I, and all you have to do is just put your new revision of the BIOS, and you can move from here. You're using the tab like is shown here. You can scroll to the files and find the BIOS that you need to update, the file, and all you have to do is just pressing enter, and it will update your BIOS. This feature I enjoyed a lot because I was able to make the proper update BIOS very easily without breaking anything, and without doing or without updating from the BIOS, because it's bad if you're doing that. It will work, but it will not crash the at least on the Gigabyte. It has the utility that you can use, and yeah, you can update the BIOS directly from the from Windows, of course. What else can I tell you? This computer will perform fine on games and all of that. All you have to do is just having a repetition. If you want to upgrade, you can upgrade the memory or the CPU, like I said before. And also, if you're able to find the 1066 modules like Gskill or HyperX, or please check the manual from the official website and see from there how if it's comparable or not. Pardon. Thank you for watching once again, and if you have any questions, please put them in my comments. Bye. See you in another video. Bye.